Hello students, how are you? I hope you will be fine at your home. Today I am Rajendra Kumar Patel, PGT Chemistry, present here for the discussion for class 12, unit number 3, that is electrochemistry. So students, today's topic for the discussion, it is electrochemical series and its application. So now we will see today what is electrochemical series and how can we use it. So students, in my previous lecture I have told you that by using standard hydrogen electrode we can calculate the standard electrode potentials of different elements. So when the scientists they calculated standard electrode potentials of different elements, then they arranged that these elements in the increasing order of their electrode potential. So by arranging electrode potential, they prepared a series which is known as electrochemical series. It means simple. What is electrochemical series? It is a series which is obtained by arranging the standard electrode potentials in increasing order of different elements. So now students, see here in your book in table number 3.1, this electrochemical series is given. For today's discussion I have selected some elements from that series. Okay, these elements are fluorine, chlorine, silver, iron, third copper, hydrogen, nickel and some more elements. These are not enough elements, some more elements are also given in that electrochemical series in our book. So for our discussion I have selected some elements. Okay, so in this series you can see the electrode potential of fluorine, it is 2.87. This 2.87 is positive. Okay, so positive 2.87. In my previous video I have told you that if electrode potential it is 0, because we have calculated electrode potentials by comparing with C, standard hydrogen electrode. So the standard hydrogen electrode, its potential is 0. And now if we measure, as in case of zinc, the electrode potential of zinc, it is minus 0.76. What does it mean? It means that zinc, it is more reactive than hydrogen, and if we prepare a cell by using zinc and hydrogen, then zinc, it will act as anode and hydrogen will act as cathode, because zinc is more reactive than hydrogen. And the electrode potential of copper, it was positive, it is 0.34. as you can see here, the electrode potential of copper, it is plus 0.34. it means copper is less reactive than hydrogen. Okay, so if we prepare a cell by using copper and hydrogen, then we will find that copper, it is acting as cathode and hydrogen as anode. So hydrogen electrode, it can act both as anode and cathode, depends on the tendency or the electrode potential of second half cell. So here students, the electrode potential of fluorine is plus 2.87, then hydrogen it is 0, then lithium it is minus 3.05. So here I am highlighting 3. 3 means what? First is hydrogen, this one is 0, lithium, this one is negative, and fluorine, it has positive electrode potential. So we have 3 types of electrode potential: positive, 0, positive, neutral and negative. So now see how can we use this electrode potential electrochemical series. So first application, it is to compare the reactivity of elements. The reactivity of elements, it means in class 10 there was a double displacement reaction, okay, or single displacement reaction we have studied. In that reaction we what we did, zinc, it was dipped in copper sulfate solution. Zinc, it was solid, and copper sulfate, it was aqueous. So the color of copper sulfate, it is blue, and the color of zinc, it is silvery white. Okay, color of zinc it is silvery white, and solution color is blue color for copper sulfate. So when we dipped zinc granules in copper sulfate solution, after some time we observed that the blue color of the solution it converted into transparent solution. Why? Because of the displacement reaction ZnSO4 and Cu. Due to the formation of zinc sulfate, the solution turns from blue to colorless, and there was a reddish brown deposition on zinc granules. The color of zinc granules, it was silvery white, but after reaction the zinc granules, their surface it turns reddish brown because of the deposition of copper. So what is the meaning of this reaction? This reaction indicates that zinc is more reactive than copper. So zinc is more reactive than copper. Remember this line. What? Zinc is more reactive than copper. So now here we have to compare the reactivity of elements. Now see, we know that zinc is more reactive than copper, so compare their electrode potential. Copper, it has electrode potential, that is this one. This copper has electrode potential 0.34, it is positive, and the electrode potential of zinc, it is minus 0.76. So from this reaction we can conclude that the elements which have negative electrode potentials are more reactive than the elements which have positive electrode potential. And not only negative and positive, it was the concept for zinc and copper. The ultimate concept is the elements which have greater electrode potential or higher electrode potential are more reactive than the elements which have smaller electrode potential. So if we compare any two elements, for example, if you compare these two elements, iron and nickel, if we react these two elements, then iron will be more reactive than nickel. Why? Because iron, its electrode potential is minus 0.44, and nickel, its electrode potential is minus 0.25. It means iron which has less electrode potential can replace nickel which have high electrode potential. So less electrode potential, it can replace high electrode potential elements. Okay. So this was the reactivity. So what is the conclusion? Conclusion is the lower elements can replace upper elements. Okay. Means if you compare any two, then the elements which is present at lower point, they can replace the elements of present in upper side. It means copper, if you react copper and zinc, then zinc is more reactive than copper. If you react copper and nickel, nickel is more reactive than copper, means nickel can replace copper. If we react silver and copper, then copper can replace silver. So the lower elements, they can replace higher elements from their solution. So on moving down in a group, reactivity increases. Second, to compare oxidizing power and reducing power. Now students, from the same reaction, here we are going to conclude that, just take an example of two elements. These two elements are, first element, it is zinc plus copper sulfate, it means Cu2 plus. When they are reacted, they form Zn2 plus and Cu. It means this zinc is oxidizing and copper is getting reduced. Okay, zinc, it is undergoing oxidation and copper is undergoing reduction. So if zinc is undergoing oxidation, it means zinc is reducing agent. Okay, zinc is reducing agent and copper is oxidizing agent. So here copper, this copper is what? This copper is oxidizing agent, this zinc is reducing agent. So now compare the oxidizing and reducing power. Upper is oxidizing, lower is reducing. So from this point we can conclude oxidizing power. As we move down in this series, okay, what? As we move down in the series, reducing power increases. So lithium, this one is the strongest reducing agent. Okay, because here see copper, between copper and zinc, zinc is what? Here zinc, it is undergoing oxidation. Zinc is undergoing oxidation. It means zinc is what? Zinc is reducing agent, and copper, which is undergoing reduction, is oxidizing agent. Oxidizing agent, it is copper. So see students, zinc, this one is reducing agent, this one is oxidizing. So as we are moving down in a group, reducing power increases, and as we move upside, okay, then oxidizing power increases. So oxygen, it is strongest, fluorine, it is strongest oxidizing agent, and lithium is strongest reducing agent. So here see oxidizing power. What is change in oxidizing power? As you move down in this series, oxidizing power, it decreases. Okay, and reducing power, as you move down in this group, reducing power increases. Okay, this is the relation. So on this basis, fluorine is strongest oxidizing agent and lithium is strongest reducing agent. Okay, so this is the conclusion, or this is the application of electrochemical series. First application, this application is to compare reactivity of elements, their oxidizing power and their reducing power. Now students, see second application, to compare reactivity with hydrogen. So in this reactivity, as you move down in a group, okay, down in a group means what? Now we are going to compare the reactivity. Where is hydrogen? Hydrogen is here. So we will compare the reactivity of hydrogen with the elements which are present below hydrogen and the elements which are present above hydrogen. So here, to compare the reactivity, we will take some example. First example is, take reactions of first zinc plus HCl. Okay, zinc plus HCl, it forms ZnCl2 and H2 gas. This hydrogen gas is liberated. So what does it mean? Here you can see this zinc is replacing hydrogen. It's a single displacement reaction. So zinc is more reactive than hydrogen. It means zinc can liberate hydrogen from its solution. So the elements which are present below hydrogen, or the elements which have negative electrode potential, can replace hydrogen from its solution. So this reaction is possible. Now take second reaction, that is Ag plus HCl. We think that it will form AgCl2 plus H2 because this is a metal and metal reacts with acid to form salt and hydrogen gas. Okay, so is this reaction possible? No, it's not possible, because silver is what? Silver is the noble metal. It doesn't react with acid. So if it is not reacting with acid, it means this reaction is not possible. So now from this point we can conclude the elements which are present above hydrogen cannot replace hydrogen, means they are less reactive than hydrogen, these are more reactive than hydrogen. So here we have 2 points, negative electrode potential elements, they are more reactive than hydrogen. Positive electrode potential elements are less reactive than hydrogen. So here, to compare reactivity with hydrogen, what can we conclude here? Here we can conclude that the elements which have, here the point is, negative electrode potential, okay, can replace hydrogen or displace hydrogen, and positive electrode potential, they cannot do so. Okay, it means these are less reactive than hydrogen, these are more reactive than hydrogen. This is the second point. Third point, to predict feasibility of reaction. Feasibility means possibility of reaction. Means if we mix two elements, two solutions, or one element and one solution, then will reaction take place? It's a question mark, because we don't know. When you enter in chemistry laboratory, you don't know which element is more reactive and which one is less reactive. So how can we compare? Will the reaction take place or not? So here, how can we predict? So how can we predict? Simple point. And the point is, in a chemical reaction, means if it is a redox reaction, then definitely one element, it will undergo oxidation and second element will undergo reduction. So now students, let's see. I am writing an equation here. Fe2 plus nickel, they form Fe and nickel 2 plus. Okay, so now here the question. This Fe, this iron is getting what? This iron is getting reduced. This iron is getting reduced, and nickel, this nickel is getting oxidized. It means, as you know, oxidation always and always takes place at anode. So which is undergoing oxidation? Nickel. So nickel will act as anode, and iron, which is undergoing reduction, will act as cathode. So which one is anode? Here in this case, anode is nickel and cathode is iron. Here see, anode is what? Nickel, and cathode, it is iron. So now we are going to predict whether this reaction is possible or not. So to confirm the possibility of reaction, we will calculate E0 of cell, and you know E0 of cell, it is equal to E0 cathode or minus E0 anode. Okay, so here see, which one is cathode? Cathode is iron. So what is the electrode potential for iron? So for Fe2 plus, you can calculate minus 0.44. This is minus 0.44. Okay, this one is iron, and the electrode potential for anode, nickel is acting as anode. So the electrode potential for nickel, it is minus 0.25. Minus 0.25. This is electrode potential of nickel, and here we have to find the difference. So what will be the answer? The answer will be minus 0.44 minus into minus, it is plus 0.25. So the answer will be minus 0.19. Since the electrode potential of cell, or simply we can say E0 cell, means what? It is EMF. Since EMF of cell is negative, so the reaction will never take place. Remember this thing, underline this line. If E0 cell or EMF, it is negative, reaction is impossible. Okay, reaction is impossible in forward direction. This reaction will take place in backward direction. And if EMF is positive, then the reaction will take place. So this reaction in forward direction, it is not possible. This reaction is possible in backward direction, because in backward direction, Fe, it will get oxidized and nickel, it will get reduced. So in that time, Fe will act as anode and nickel will act as cathode. So in that case, electrode per E naught cell, it will be positive. So here in third point, what is the what can we conclude? The point is, if EMF of the reaction is positive, the reaction is possible. If EMF is negative, reaction is impossible. Got it? So this is the third application. Now come to fourth application. This application is to calculate EMF of cell. Simple point. To calculate EMF of cell, will take two values. First for anode and second for cathode. Just find the difference. Then you can calculate EMF of cell. So these are the applications of standard electrode potentials or electrochemical series. After this discussion, now here I am going to discuss some important points in our daily life. In daily life, you can see why curd is not stored in metal containers like zinc. Why? Means, can we store curd into zinc container? No. Why? Simple point. Zinc container, it is made by zinc. In curd, lactic acid is present. So zinc reacts with acid to form what? Salt. So if we store curd into zinc container, then this curd will react with zinc and will form another substance. So curd, it will get destroyed. So that's why we cannot store curd into zinc container. Like that, what are some more applications of this series? From this series we can conclude also prevention from rusting. In class 10 we have discussed how can we prevent rusting by applying paint, means by barrier protection. Second was galvanization, and third is by sacrificial protection. In galvanization, iron articles, these are coated with zinc. So iron and zinc, these are in contact. So see, which one is more reactive, iron or zinc? Zinc is more reactive than iron, because as we move up in this series or as we move down in the series, so if you move down in the series, reactivity increases. It means zinc is more reactive than iron. So first zinc will react with the external agents like moisture, acid or some other chemicals. So first zinc will react, iron is safe. So this is the galvanization process. By sacrificial protection, you see the iron poles, these are connected via wire. So if you see the underground structure of the pole, then you can see there a magnesium block is attached with iron. Why magnesium block is attached with iron? Because magnesium is more reactive than iron. Okay, so in that case, magnesium, it will get oxidized and iron, it will be safe. So here magnesium is sacrificing itself. Okay, so this one is sacrificial protection. So now sacrificial protection, in sacrificial protection we are using the metals or the elements which are more reactive than iron. So how can we find the reactivity, or how can we compare the reactivity of elements? From this electrode potential. Okay, less electrode potential, more reactivity. More electrode potential, less reactivity. Okay, so these are the applications of standard electrode potentials and electrochemical series. That's all for today's discussion. Thank you very much. If you like my lecture, please like and subscribe. Thank you.